Okay, in this video we're going to have a look at a range of locus questions, beginning with a fairly straightforward one, but right through this we're concentrating on looking at the graph, graphing it, seeing where things lie. For these two parabolas we're going to try and find the focal focus, the vertex and the directrix. Okay, now for all of these parabolas what we're looking for is that this x squared or y squared equals 4ay. So the a is the focal length, this a is the focal length, and that then gives us position above and below the vertex. So in the first question, x squared equals 8y. Well, I'll just work down in this region. X squared can be written as 4, and it's always a 4, and so what the 2 becomes the focal length. Now when x equals 0, y equals 0, so we have a vertex right in the center, and that's the bottom of our graph. We know that the focal length is 2 units, so our focal point is 2 above, and there's f, and that means our directrix will run along the 2, and that is y equals, try that again, try and make it legible, y equals negative 2. Okay, now the parabola, when you're sketching the parabola, it has to have some degree of scale. So when x equals 1, what we think about when y equals 1, now we'll try x equals 1. 1 squared equals 8, so it's 1/8. So we've got a point just down there, just down here, and it's going to be a fairly flat parabola. Now, and I'd mark this point as 1/8 just to show that you know what's going on. And there's the diagram where we've got the focus and the directrix equidistant from the vertex, okay, and a concave up parabola. Let's look at the second one. Y squared equals negative 2. Now, again, down the bottom here, we've got y squared equals, in this case I've got negative 4, because I have to have a 4, and this time it's negative. So what multiplies by 4 to give 2? And the answer is 1/2, and I'll squeeze the x down there. So we've got a focal length of 1/2, but this time we've got a parabola facing the other way, y squared. This y squared is a concave left or right parabola. Because it's negative, it's concave left. So again, our vertex is at the same point. It's at 0, 0. But this time, I'm going to try and zoom in a bit. Right, this time we have a focal length of 1/2, and it's concave left. So we've got a point there, and that is my focus. And that means that my directrix runs down here where x equals 1/2. Oops, sorry about that. Try that again. X equals 1/2. Okay, now again, we've got to think about some points here. So when y squared equals negative 4/2 x, when x equals 1, well, let's work in terms of y now. When y equals 1, okay, and we just have a look at the graph again. Okay, when y equals 1, well, we can rearrange this thing and we get a parabola like, again like that, where you'd put the points on here, or one of those points to show that you substitute correctly. But there's the first example where we're just trying to figure out which way the parabolas go. Most importantly, you always try and put it in terms of this. And I'm just going to give you a 30-second intro now, and then we're going to look at a second video in a second, at a parabola that's off the vertex. And what we would see when we have something off the vertex down the bottom here, x squared, well, x minus h squared equals 4ay minus k, and the h and the k represent the coordinates of the vertex. So if I had x minus 1 squared equals 4a, and it's getting a bit messy down there, y plus 2. Okay, then our vertex is positive 1, negative 2. Okay, positive 1, negative 2. This point here, okay, becomes the vertex. Now, it's concave up because it's an x squared, and so we could then figure out with numbers what this would look like. But minus h minus k give us a parabola where the vertex is somewhere other than the center. I'll do another video to show you that.